Hey everyone, today we are going to solve the Daily LeetCode challenge of 2nd January 2024, and the problem statement is convert an array into a 2D array with conditions. So let's first understand the problem statement. So according to the problem, we have been given an integer array nums. Okay, and now according to the problem, we have to convert this 1D array into a 2D array. That is, convert 1D array to 2D array. Now, while converting this 1D array to 2D array, we need to follow certain conditions. Now, what are those conditions? So the first condition is that all the elements which we'll be adding in this resulting 2D array should be present in this nums array. It means that we cannot put 6 in the resultant array because 6 is not present in my nums array, right? So the first condition is elements of 2D array must belong to nums. Now, what's the second condition? Now, when we'll create a 2D array, we'll have it something like this. We'll have one row, then we'll have another row, and similarly, we'll have another row. So each of the element of these row should be distinct. It means that if I'll have this row, then each of its elements should be different. Each of the element of this row should be distinct, right? We cannot have duplicates element in the same row. So the second condition is each row must contain distinct element. Let me capitalize this D. Distinct elements. And what is the third condition? The third condition is that we should have minimal rows in 2D array. Now, what do I mean by this? So we can create this 1D array nums to a 2D array by simply writing each of the element in a new row. Like we can write 1, we can write 3, we can write 4, we can write 1, 2, 3, and 1. And we can assign each of them in a new row of the resultant 2D array, right? So are we satisfying the first condition? Yes, we are satisfying the first condition. Why? Because each of the element of 2D array is present in nums. Are we satisfying the second condition? Yes, we are satisfying because in this row we have only 1, in this row we have only 3, in this row we have only 4, in this row we have only 1, in this row we have only 2, and similarly 3 and 1. So each of the elements in each row is distinct. But are we satisfying this condition that minimum number of rows should be present in the 2D array? So it's no, we are violating the third condition. Why? Because there is a better solution, there is a better possible solution than this. Why? Because we can have a minimum number of rows in there. So let's see how we can solve this problem. So let's take this example and let's put each of these elements in a row so as to create a 2D array. So let's say I have a 2D array and this is the row 1 of my 2D array. Okay. So now let's add these elements to my row 1. So can I put 1 if this is my first row? So can I put 1 in this? Obviously, we can put 1 because we are satisfying the first condition because one is present. Wait, let me write it like this. Okay. So say for example, this is our 2D array and this is my first row of the array. Okay. So we can put this 1, we'll satisfy the first condition. We are satisfying the second condition because initially this first row is empty. So we can put this 1. And after that, let's move, since we have used this one, so let's cut it off and let's move to another element. So can we put this 3 in the first row? Yes, we can put this 3 in the first row. Now let's move to the next element. So can we put this 4 in the first row? Yes, we can put this 4 in the first row. Now let's move ahead. Can we put this 1 in the first row? So the answer is no, we can't put this 1 in the first row. Why? Because we are violating the second condition, which we need to create a new row. Say this is my row 2, and in the second row we have to put this one. So we'll put this one in the second row. Now we'll move forward. Now we have 2. So we'll first check, can we put this 2 in the first row? So yes, we can put this 2 in the first row because we don't have any additional 2 present. Now we'll move to this 3. Now we'll see, can we put this 3 in the first row? So the answer is no. Why? Because again, we are violating the second condition. Because we are already having a 3, we cannot put this 3 because it will result in duplication. So we'll simply put this 3 in the second row. Now we'll come to this one. Can we put this one in the first row? No, because 1 is already present. Can we put this one in the second row? So the answer is no. Why? Because 1 is already present in the second row, and we should have only distinct element in each row. So we'll create a new row and we'll put this one here. And then we'll move to the next element. So we don't have any more elements. So this is our answer. Now, one thing we can note here is that what is the number of rows that we are getting in our resultant 2D array? So it's nothing but 1, 2, 3. So we are having 3 rows. Now, can we somehow relate the number of rows from the problem statement? So the answer is yes. So here we can see that we are having, what is the count of 1? Let's write down the count of each element. Here we are having 1, here we are having 1, here we are having 1. So we have the count of 1 as 3. Here we are having 1, 3, here we are having 1, 3. So the count of 3 is 2. We are having 1, 4 and only 1, 2. So the count of 4 is 1 and the count of 2 is also 1. Now we need to note that which element is having the maximum count. So all this element on the right side represents the count, and on the left side it represents the element. Okay, it represents the element. So 1 is having the maximum count, which is nothing but 3. So what we can note from here is that since the max count of 1 is 3, so it is obvious that we need at least 3 rows. We need at least 3 rows to accommodate this one in the 2D array. Why? Because see, here we are having 1 and here we are having 1, here we are having 1, here we are having 1. Okay, now if we have say for example in a case if we have 5 as the count of 1, okay, we have the count of 1 as 5. So and 1 is the element which is occurring maximum time in the array. So we'll need at least 5 rows, to accommodate all the elements by following these conditions. Why? Because if we have an array of 4, if we have a 2D array of 4 rows, then will we be able to satisfy all these 3 conditions? So the answer is no. Why? Because in the first row we can put 1. In the second row, we can put 1. In the third row, we can put 1. In the fourth row, we can put 1. But here we are having 5 ones. Now, where is the fifth one going to be? Like, where are we going to place the fifth one? We cannot put it in the first one because it will result in duplication. Similarly, we can't put it in the second, third, and in the fourth one. So, we have got an idea that whenever we are given an array, so the element, the max occurrence of the element, right, the element which is occurring the max number of time, that element's frequency is going to give us the number of rows in our resultant 2D array. So from here we are clear that the max frequency is 3, so we are going to have 3 array. Now let's see how we can solve this. So our approach would be store the elements and their corresponding frequency in a hash map. So we can take an unordered map and we can put the frequency of these all elements in it. Okay, we can store these elements and its corresponding frequency. Additionally, what we need to do is we want to find what is the row count. What is the row count? Okay, what is the row count? We need to find that as well. So how we can find the row count? So row count is nothing but it's the frequency of the element which is occurring the max number of time. So what we can do is we can come here, we can see that we can place this 1 in our hash map. So we'll have 1 and we'll have the frequency of 1 as 1. Now we'll come here, we'll have 3 and we'll have the frequency of 3 as 1. Now we'll come here, we'll have 4, we can have the frequency of 4 as 1. Now we'll come here, we'll see, since we have 1, so we'll increment its frequency. So additionally, the frequency of 1 was 1. Now it will get incremented to 2. Now we'll come here, so we'll add 2 and its corresponding frequency as 1. Now we'll come here, so we are having a 3 and we were already having a 3, so we'll increment its frequency and it will become 2. And now we'll come here, so we are having a 1 and Since we already had the frequency of 1 as 2, so we'll simply increment the frequency and it will become 3. Okay, so we have populated our hash map. What we need to do is we need to find that what is our row count. So row count is 3. Why? Because 1 is the element which is having the max frequency. So we are having max frequency. What are the frequency? We are having 3, we are having 2, we are having 1, and we are having 1. And out of all these, 3 is the maximum. So we will have row count as 3. Now we know that our resultant 2D array will have a size of 3. So so what we'll do is we'll initialize a resultant array of size 3. So our first step was to store elements and their corresponding frequency in a hash map. After that, what we are doing? We are initializing answer. We are defining 2D answer array of size. What will be the size? The size will be nothing but row count. So this is our second step. So now we'll create an answer of size 3. And this 3 is nothing but the row count. Okay. So what does this mean, that answer of size 3? It means that we are having a 0th row, 1 row, and 2 row. So we have to populate this row 0, this row 1, and this row 2. Let me write row as well. Row 0, row 1, and row 2. We need to populate this row. Now, how are we going to populate? So we'll iterate over our hash map. So the first value that we'll get from our hash map will be 1, 3. In this, 1 is the element and 3 is the frequency. Now, what we'll do is we will loop from 0 up to this 3. Okay, we'll loop till there, and up to 3 means till I is not equal to 3, means still we have I less than 3, we'll iterate. And what we will do is, for each value of I, we are going to add 1 to our answer. It means that initially we'll have I as 0. So in answer of 0, we are going to add 1. Then we'll have I as 1. So in answer of 1, we are going to add this 1. Then we'll have I as 2. So in answer of 2, we are going to add this 1. Now I will become 3. So our condition was that until I is less than 3. So since this condition got violated, so it would be over. Now we can see that the frequency of 1 was 3. And we have accommodated 3 ones in our answer. This is the first one, this is the second one, this is the third one. And each of them are in a different rows, right? Now we are done with this one. Now we'll move to the another pair. So here we'll have 3, 2. Now 3 is the element and 2 is the frequency. So again we'll iterate from I equals to 0 to 2. So it means initially we'll have I as 0. So when I is 0, so for I equal to 0, we are going to put 3 in the answer of 0. So this is the answer of 0, we are going to place a 3. Now we'll have I as 1. So in answer of 1, we are going to place that 3. Now I has become 2 and we have violated the condition because I should be less than 2. That was our condition. So it has been over. Now we'll move to the another pair. So we'll have 4, 1. Now we are having 4, 1. So here 4 is the element and 1 is the frequency. So we'll have initially I equal to 0. So for I equal to 0, we are going to place this 4 in the answer of I. So answer of I means in answer of 0, we are going to place this 4. Now 0 will increment to 1. Now since these two are equal, we are done with this pair as well. Now we'll move to the another one, which is nothing but 2, 1. So we'll have 2, 1. So again, we'll have I equal to 0. So for I equal to 0, we are going to place this 2 in answer of 0. So we'll place this 2 here. Now I is no longer less than 1, no longer less than this value. So we are done with this as well. Now we have completely iterated over all the elements of our hash map. So we are no more left with any of the elements. So it means that this is our resultant answer. Answer 2D array. Okay. So what will be our third step? So this is the first step, this is the second step, and third step would be to iterate over the hash map to populate the 2D array. Okay, so we are done with the first approach, which was using the hash map. So let's now code down this solution. So first we have to create a hash map of int comma int. Like the first would be the element and the second one would be like the value would be its frequency. So let's call it as frequency. And after creating the hash map, we have to populate it. So we are going to say that for each element of nums, we have to populate it, right? Now we were doing one more thing, and that's to find out this row count. We need to also find this row count. So let's say int row count equals to 0, and this row count would be nothing but the frequency of the element which is occurring the max number of time. So we'll say that row count would be max of row count and the frequency of the current elements. Fine. Now, after populating this hash map, what we were doing is, after populating this hash map, we have to define answer of this size row count. So now we have to create a 2D vector. Let's say answer, and its size would be this row count. Now, after defining this 2D answer, what we are doing is we are iterating over the hash map to get each of the pair, and then again we are iterating till its second value, and we are adding it in the answer. So what we are doing is, for each of the value of this hash map, we are saying that till its second value, we are going to say that answer of index. Like here we are saying, like if I is 0, then in answer of 0, we were going to put, like we were putting this value 2, right? So in answer of index, we are going to push back this value, which means current dot first. And we are done with populating. And once we have populated our answer, we are simply going to return our answer. So let's run this in the given test cases. So yeah, it's correct. Let's submit it. So it got accepted. But one thing we can see is that we are using hash map here, right? Now, if we'll come down and see the constraint, you can see that the length of nums array is at max 200. So instead of using a hash map, we can also use an array, like we can use a vector. It would be better because we know that the size of nums won't exceed 200. So instead of using hash map, it's better to use an array. So let's see how we can do it using an array. So it's the second approach. Create a frequency array of size nums dot size plus 1. So what's the size of nums? It's 1, 2, 3, 4, 5, 6, 7. So it's 7. So we'll create a frequency array of size 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. All of its value would be 0, 0, 0, 0, 0, 0, 0, 0. Let's index them as 0, 1, 2, 3, 4, 5, 6, 7. Okay. So initially what will happen, like now what we'll do is we'll iterate over each of the elements of nums, and whenever we'll find that the frequency of element, like we can say frequency of element is greater than the size of answer, Now what is this answer? This answer is our 2D array. Okay. Now whenever we'll find that the frequency of an element is greater than the size of answer, then what we'll do is we will install a new row. So say for example, our answer is of size 2. What does it mean? It means it's having 2 rows, first row, second row. And we have an element, say for example, the element is 5. And 5 is having a frequency of 3. This is the frequency and this is the element. Okay. So can we accommodate this 5 in a 2D array of row 2? The answer is no. Why? Because we can put this 5 here, we can put this 5 here. So the frequency of 5 was 3. We have accommodated 2 of the 5. But where will the third 5 go? We cannot put it here and we cannot put it over here because it will result in duplication. So whenever we'll get an element that has a frequency greater than the size of the answer, what we'll do is we'll install a new row, and then after that we'll put that 5 in the new row. Okay, so we'll follow this approach, that whenever the frequency of element is greater than the size of answer, we'll install a new row. Okay, and after that what we'll do is we'll simply increment the frequency. So let's see how are we going to do that. First of all, we'll come to this one. We'll see that what is the frequency of 1. So in this frequency array, we have the frequency of 1 as 0. Now we will check that is this frequency greater than equal to the size of the answer. So what is the size of answer? So initially when we are creating this answer, its size is 0. Okay, we don't have any rows initially. Okay, so we'll see that the frequency of element is greater than equal to the size of the answer. So what we'll do is we will install a new row. So say for example, this is our new row. And after installing the new row, we will insert this element in the new row. So this element has been inserted, 1. Okay. And after that, we'll increment its frequency. So we'll increment the frequency of 1 from 0 to 1. And we'll move to the next element. Now here we will see what is the frequency of 3. Frequency of 3 is 0. And is that greater than equal to size of answer? So what is the size of our answer? The size of our answer has now become 1. Why? Because we have installed a new row, right? We have installed a new row. So it's now the size of the answer has become 1. Now we'll see that our frequency is 0 and size is 1. So frequency is not greater than equal to size. So we won't install any new row and we'll simply put this 3 over here. Now we'll move forward. Now we'll see and before moving forward, we have to increment the frequency of 3 from 0 to 1. Now we'll come here. We have this 4. Now we'll see what is the frequency of this 4. The frequency of 4 is 0. Is 0 greater than equal to 1? No. So we won't install any new rows and we'll simply put this 4 in the first row itself. Now, before moving forward, we have to increment the frequency of 4. And now we'll move forward. Now we'll come to this one. Now we'll see what is the frequency of 1. The frequency of 1 is 1. Size of answer is also 1. So the frequency of our element is greater than equal to size of answer. That is 1 is greater than equal to 1. So it's true. So we need to install a new row. So we are going to install a new row, and after installing the new row, we are going to place this one in the new row, and then we'll increment its frequency to 2 and we'll move forward. Now we'll see what is the frequency of 2. The frequency of 2 is 0. Wait, before that, we need to see that now the size of answer has become 2. Okay, so let's change this to 2. Okay, now what's the frequency of 2? The frequency of 2 is 0. So is 0 greater than equal to 2? No, it's not greater than equal to 2. 0th index, we are going to insert this 2. And after that, we are going to increment its frequency from 0 to 1. And then we'll move to the next element. Now we have come to 3. Now what is the frequency of 3? Frequency of 3 is 1. So is this 1 greater than equal to 2? The answer is no. Now we are going to insert this 3 in the answer of 1. In the answer of 1, which is in this row. We are going to insert this 3. Now after that, we'll move to the next element, which is 1. Now we'll see what is the frequency of 1. Frequency of 1 is 2. So is 2 greater than equal to 2? Yeah, it's true. So we are going to install a new row and we are going to put this one inside the new row and we are going to increment its frequency and we'll move to the next element. Now we'll see that we have completely exhausted the array and we have got the 2D answer array, which is nothing but this one. So let's code this solution. Okay. So what we have to do initially, we have to create a frequency array and its size would be nums.size plus 1. Now, after creating this frequency array, we are going to create our answer array, which is a 2D array. Now, after that, we will iterate over nums. we were doing while iterating over nums? We were first checking if the frequency of element is greater than or equal to size of answer or not. So we'll check if frequency of current is greater than or equal to answer dot size. So what we will do in this case, we were installing a new row, right? We are installing a new row. So we'll say answer dot pushback a new row. And after that, what we were doing is inserting this element in the answer of frequency, right? In the answer of frequency. So what we'll do is we'll say answer dot in answer of frequency of current. Like if the frequency of current element is 0, then we are going to place it in the 0th row. If the frequency of the current element is 1, then we are going to place it in the first row. So we'll say dot pushback the current element. Now after that, we are simply incrementing the frequency. And we'll return answer. Now let's run this. Let's submit this. So it got accepted. Talking about the time complexity and space complexity. So the time complexity is order of n. Why? Because we are here, you can see that we are completely iterating over all the elements of nums. So if the size of nums, is n, then here we are iterating over the nums. So it's taking order of n time complexity. And why the space complexity is n? Since we have created a frequency array of size n here. So that's all for the LeetCode challenge. Thank you.